So storage capacity, the storage capacity of percolation tank is defined as the volume of water stored in the tank up to the full tank level. The storage capacity can be computed by using the contour plan of the water spread area of the tank. The total capacity of the tank will be the sum of the capacities between the successive contours. The smaller the contour interval, the more accurate the capacity computation will be. The summation of all the volumes between successive contours will required for computing the storage capacity of the tank. When a contour plan is not available and only the area of the tank at FTL is known, then the effective volume of the tank may be roughly computed as the area multiplied by 1/3 of the depth from FTL to the deep bed of the tank. The tank is designed to ensure maximum utilization of its capacity. A structure of optimum capacity is most cost effective. A underutilized structure leads to unproductive expenditure incurred on extra earthwork. From the contour maps and digital elevation model, the low-lying area of the SVNIT campus is identified. This is another principle which we have seen in the design guidelines, that you have to choose such an area that it have a natural depression so that the runoff can be diverted into that area. The area available for constructing a pond is 40,000 square meter. The depth of groundwater table at proposed location is observed as 9.13 meter. So in our previous lecture, what is the depth required for the recharge well? What is the depth of water required for the recharge well? What is the preferable depth of water is required? Can anybody tell? Hello. You can unmute and tell me.
Sir, they are replying by 4.5 meter and Rakesh is
8.
saying 8 meter.
8 meter is the correct answer.
8
The
meter.
depth of groundwater table which is required is 8 meter. And here you can see the depth of water table observed immediately after the monsoon season is 9.13 meter. That means that we can construct a recharge pond or percolation pond in SVNIT campus. The proposed depth of the pond is considered to be 3 meter. Then the total capacity of pond is area available into depth of the pond, which comes out to be 1,20,000 meter cube. Now comes the design of bund. The tank bund for all practical purposes is a small size earthen dam, and its design and construction should be carried out in accordance with the principles applicable to earthen dams. IS 12169 criteria for design of small embankment dams. This is the IS code which one can refer for designing of bunds. IS 12169, this can be referred for design of tank bunds. So tank bunds in India are mostly of type A. So I have shown you type A, type B and type C. In type A, there is no structure inside the bund. In type B, it's a zone type. And in type C, it is a diaphragm type. So type A and are constructed with soil excavated from pits in the immediate vicinity of the bund and transported to the bund. The upstream face of the tank bund is generally riveted with stone apron or riprap so as to protect it against erosion. And if this is done, then the upstream slope generally adopted as 1.5:1 or and 2:1 for downstream slope. The code of practice for stability analysis of earth dam for slope of the bund is IS 7894 1975 may be used. IS 8237 code of practice for protection of slope for reservoir embankments, that is for stone apron or riprap. This may be referred for the design of upstream protection and riprap. This code IS 7894 1975 be referred for code of practice for stability analysis of earthen bunds. And IS 12169 criteria for design of small embankment dams can be referred for design of embankments. So three codes gives you clear idea about the stability, that riprap design, as well as the bund design. The top width of the bund is provided as 1.5 meter. The freeboard of is proposed as 1.2 meter. The three recharge shafts are proposed in the middle of the pond. In case of full pond condition, it can recharge the groundwater. What is this recharge shaft? These recharge shafts are provided in this middle of the pond, where when the water level increases in the pond above the full supply level, what will happen? It will start percolating into, it will start discharging into this recharge shaft, and these recharge shafts are taken up to the groundwater level or the strata where the recharge can be done easily. The top of the recharge shaft pipe is equal to the full reservoir level of pond, but 50 mm less than the top of overflowing weir. So if you have made the provision of overflowing weir, then the recharge shaft pipe is kept equal to the full reservoir level, but it should be less than 50 mm less than the overflowing weir. The waste surplus weirs are constructed for discharging the excess water from the tank into the downstream channel after it is filled, so to avoid the rise of water in the tank above the maximum water level. The water will start spilling over the crest of this escape weir as and when it rises above the full tank level, and the discharging capacity of this weir will be so designed as to pass the full flood discharge, likely to enter the tank with a depth over the weir equal to the difference between FTL and MDL. In the previous slide, we have seen that how the weir be designed. Can anybody tell me that how the weir be designed? Overflow weir be designed? How the capacity or the dimension of overflow weir be decided? Yes, I will see. Anybody is replying in the chat box?
So based on the shape of the weir.
No. We discussed in the just previous slide, a previous presentation rather. What was it? You to consider maximum intensity, right? That is maximum intensity per hour. And for that intensity, what will be the runoff generated from the area? That is considered as design discharge for the weir, which you will be constructing as an overflow weir section for a pond. The difference between FTL and MWL is proposed as 0.5 meter. So this is the proposed plan of a pond. You can see here, this is imaginary centerline axis, and all the radiuses and curves are designed keeping in mind the landscape that is also shown over here. The section of this, detailed section of this, that is given in the next slide, wherein you can see here, as we have discussed, the top width of the bund, which is kept as 1.5 meter, the wrap up bund slope, that is taken as 2.1:2. Here the upstream slope, it is taken as 1:3.5. 1:3.5, that is 3 meter vertical and 4.5 meter horizontal. This is the slope which is protected with the stone pitching, rubble pitching. In the center, as I said, that this is one number. If you go like this, there will be second shaft, and then again there will be third shaft. So this is the recharge shaft, which is provided in the pond, wherein apart from that of the natural recharging through bed of the tank, the water is recharged through the recharge valve, and recharging is taking place through recharge valve whenever the water level rises above this water level, what will happen? It will start discharging into the recharge stop. So this is recharge valve, and you can see the dimension of it is also shown 0.4 meter, while the depth of the tank is the top of the recharge valve is 3.4 meter, while this depth is approximately 3 meter of the depth of the pond. So whenever the water level rises above that, what will happen? It will automatically start recharging through this is excess water, because the water will be recharging through the bed of the pond. Apart from that, in case of full pond condition, the additional water that will be diverted into the groundwater through these 3 recharge valves, which are proposed to be constructed inside the pond. So this is one pond, and the proposed depth of recharge well, as I said, up to 9 meters strata, as we have seen the borehole data and analysis of soil, and that we have seen that up to 9 meter the depth of water is good for the storage, recharging of the water, and therefore in this case we have proposed the depth of recharge well as 7.5 meter. So this was all about the design of recharge pond based on the guidelines which we have discussed in our first slide presentation. In the last slide presentation, third slide presentation, I'd like to show you certain field problems, wherein when we are designing the pond, one may come across the varieties of issues and how these issues can be solved. That is number one. And number two, I want to introduce these softwares which can be used for the purpose of design of slope, as well as for the analysis of design of seepage, either through the bottom of the pond or through the embankments. So in the first part, I wanted to share with you the consultancy work which we have carried out for Pal Lake, Pal, Surat. The issue in this particular tank was it was not having water after the monsoon, immediately after the monsoon season, and the problem was that how to have water in this pond for a longer time period immediately after the monsoon season. So no water retention storage in the lake immediately after the monsoon season. So we have prepared the contour map of the lake, and the first thing which we have observed was the pond, the area of a pond where this pond is proposed, that was higher than the adjoining areas. So you will see here, this is the picture, and maybe this may be a village pond some years back, but because of urbanization, you can see that this is the Pal Lake. These are all around. You can see this is the lake, and all around you can see it has become densely populated, right? Even the roads around the pond, right, and the storm drainage line which were laid by municipal corporation to take the storm water out of these areas, right? Due to that, the runoff into this Pal Lake that has been reduced. That is one thing. Second thing, after the monsoon season, the water inside the pond, as we have discussed just now, that we want to retain water for a longer time in this particular lake. You will see here, we have find it out the area, elevation, and cumulative storage curve based on the analysis, and find it out that what may be the solution, whether we can go for increasing the depth of the pond, which will result into the increase in the storage capacity, or we have to suggest some another solution for it. This is the another picture wherein you can see that this picture is specifically I have added into slide. You can see here you can see the water, but there is no water here. At the same time, you may observe that this part is having sand, and as we discussed that the sand is very good material for the recharging purpose, and therefore one of the reason for no storage retention in the pond is the characteristic of the soil in this particular pond. Those from Surat, for their information, this particular section is the section of a Hope Bridge. The Hope Bridge, you know that its lifespan is over and corporation has demolished that Hope Bridge. One of the span of that Hope Bridge was placed in this particular pond. So the soil characteristic is one of the reason which was responsible for early draining out of the pond. You will see that the rainwater collection chamber considerably, which is provided in the green areas, but looks slightly above the adjoining ground, and because of that it may result into ponding of this area. This is the another view of a manhole which is which catches the runoff, surface runoff, and diverts into the pond. You will see here, because of no proper slope arrangements, this has resulted into formation of gully. So when we have discussed about design of pond, that time we discussed about the slope of the pond, slope of a bund of a pond. So if proper care is not taken, what will happen? So this picture shows you that when there is a heavy rainfall, it will result into the gully formation. You will see then our next picture in which you will see that this entire region, that gully formation has happened, that whenever there will be a rainfall, though there is a provision, here is a collecting drain, this side and this side, both the sides, but due to rainfall, these drains may not be sufficient or may be designed in such a way that the water, instead of flowing up to two side drains and draining out of it, it directly drains over the slope of the pond, and therefore it has resulted into what you can say gully formation on the slope of the bund. Then what is the solution? If you see such type of a thing, then if you want to protect the slope, what is the solution? You will see that the next slide, which is at Lakeview Garden, Piplod. Again, this is adjacent to our SVNIT campus. The wall of Lakeview Garden and SVNIT campus wall is common. And here you will see that this is pond, and here you find that the slope of or the bund of the pond is protected by gabions. These gabions are approximately 2 feet 60 centimeter, and in a height approximately it is 5 meters approximately, right? That is protecting, that has been constructed. This gabion stone wall has been constructed on entire periphery of the pond, and hence that protects the retaining wall or the wall which is constructed, or a bund which is constructed to store the water inside the lake. So this is the picture of the gabion slope protection wall with wire mesh that is shown. This is a real picture of Lakeview of Piplod Garden. This is another view of Piplod. Yeah, but in this, if you will see, apart from that of the gabion wall, to avoid the seepage of water through the bund, through this what we can say the embankments on either side of the pond, the geosynthetic material is used. This is a geosynthetic material, right, which prevent the seepage of water. This will prevent, yeah, percolation will take place in the center of the center of what we can say in the through the bed of the pond, but around the pond there are some structures constructed, some play areas constructed, some landscape is developed, and to protect that landscape again either falling down or getting settled, this geosynthetic material is placed behind the gabion wall, which prevents the seepage of water through the bank of the pond. So this is the another picture which shows that how the geosynthetic material can be used for the prevention of seepage through pond. This is the picture which will show you, which is when we read in the book or IS code or some design guidelines, we are not ready to understand, we are not ready to believe the seriousness of the natural drain. Here you will see that there is a pipe, and whenever there is a flow from the adjoining areas, that will flow through what you can say these particular pipes into the pond. At the same time, when there is a excess flow of the water, I don't know, I have not confirmed that, but in that case, if there is a gate at the outlet of this particular pipe, this can be used as avoiding or taking the excess water out of the pond. So it serves two purposes: draining into the pond under normal conditions and draining out of the pond in case of flood conditions or pond full conditions. So this pipe has been provided, you can see over here, and this is the gabion wall again. This is, as I said, that the geosynthetic material, and as I said that on the other side of the pond, this is the area which has been developed. Some landscape is also developed in the center of behind this particular pond, right? So to protect this area from the settlement, it is very much required that there should not be any flow of water from this side to this particular area, and therefore this geosynthetic material has been used, right? Then the next which I am going to show you, that is application of software. And when I am showing you the application of software, this has been taken from Issues and Measures for the Conservation of Water in Urban Pond, submitted by Jariwala Keval and Vijay Yadav as a thesis to Gujarat Technical University GTU Ahmedabad in 2018. There are two software, that is Slope W and Slope S. This Slope W is used for the analysis of slope oblique W. It is, I think, a part of GeoStudio software, and in GeoStudio you have slope W analysis, and this slope W analysis be used for checking the stability of the slope. And therefore the steps are shown over here: create problem, workspace and analysis properties, draw or import region from CAD drawing, define material properties, define set of trial slip surface, define hydraulic boundary condition, solve your analysis. Means do slope stability analysis, and whether it is safe or not, that you can get it as a result. So slope as a stability analysis tool, Slope W, right? These are the steps which are used in the Slope W software for analysis of the slope against the failure. So this is the main window of slope stability analysis, where you will have number of options. You have to select one out of that. You have to give the parameters which are required. After giving these parameters, you have to give input option. In input also you have number of options which you can give, and using that you can carry out the slope stability analysis, right? Then This is the seepage analysis tool, that is SIPW, that is slope W, and here it is a slip W. So these are the steps for carrying out seepage analysis using SIPW software. These are the main window of slope stability or SIPW. In that there is an option you can see here. It is a SIPW analysis, and after going for that, you have to give the required inputs, which will result into boundary conditions, create model for lake in domain with mass generation. So this is the model which is created using that particular software. Geometry created in program and assign the soil properties, that is materials 1, 2, 3. You can see here different colors. This is 1, this is 2, and this is 3. This is 1, this is 2, and this is 3. So this is material 1 depth, this is material 2 depth, and this is material 3 depth. This is the pond which we have considered with the actual conditions, which will be given here, and results obtained after simulation for 3-meter depth. So when there is a 3-meter depth of the water in the pond, what will be the velocity and magnitudes, right, of this is for seepage analysis. You will find the various seepage rates over here, that how it is taking place, right, through the side as well as through the bottom of the channel, right. This is another at 2-meter depth of flow of water. This is at 1-meter depth of water. Then slope stability, you will see here there are number of lines of different colors. So following the methodology or steps which were given in the previous slides, you will have the failure of the slope for various factor of safety. Usually the factor of safety we consider specifically of one value. Here you will get opportunity as you go on increasing or decreasing the factor of safety, what will happen to your slope, right? How it will behave under the various factor of safety conditions. So that is shown over here for various depth of water. This is for one depth of water. Like that, you can have 3-meter, 2-meter, 1-meter depth of, or even pond empty condition. Pond full condition, how your slope behaves. Pond empty condition, how your slope behaves. That is also possible to find it out using the slope W software. So this is again a slope stability result for empty lake condition. So here this was full lake condition, right? The water level was full. Here it is empty, and when there is no water, how this particular slope will behave, embankment will behave, that you can able to I find it out using this specific software. So with this, I thank you very much for your patience, listening and attention. I can take any questions if you have, or we can discuss also if you want anything, right? Or specifically you want to ask. Yes. Any questions are there? No questions I see.
Sir,
Since
there are
the soil
questions
type is
in chat box. Should I read
Is-
for you, sir?
any Ayushi?
There are questions in chat box, sir. Should I read?
You read one by one.
Yes, sir, I'm reading the questions. Sir, Karan Gupta is asking, when it is said it is constructed on second and third order stream, does it mean greater than second order, fourth order will also be okay? He's asking.
See, all it depends upon the magnitude or volume of water you wanted to store. I'll share you. I have received a call from one of the university from Rajasthan, and they wanted to go for that. That was also an academic campus, and they wanted to go for conservation of water. When I asked data from them, that please provide the data, rainfall data, so I have collected from website and all that. But when I asked for the topography data, because the construction work was going on in that institute, they have provided the data of soil, and to my surprise, 30 centimeter from the ground there was hard rock. Now tell me what to suggest. Right. So it depends upon, number one, the institute was located in Rajasthan. So already it was having less rainfall. Number two, even though they wanted to conserve the water, the topography was 30 centimeter below the ground, there is a hard rock. So cost of excavation, suppose if I am recommending a pond, small pond, number one, it will be only for a storage purpose. It cannot be used for, it will not serve the purpose of recharging. That is number one. And number two, that at what cost the storage is to be done. Because if you are going for excavation of pond of a considerable size, it will be a costly affair. And they were having limited budget. So under such circumstances, one has to look at the hydrogeological conditions, hydrological considerations, and then one has to plan for the percolation pond or recharge structure.
Okay, sir. So the next question is, how does the top width affect the strength of the structure? Does increasing top width above the guideline increase the strength or reduce the strength?
Who has asked this question?
Sir, Karan Gupta.
Sir, no bread is free in this world. If you increase the width, if you increase the size of the bund, the cost of pond will increase. So you have to have it economize, and to go for the economic cost, the recommendation are made for it. So safety is one factor, protecting for the seepage against the seepage is another factor, and the third and most important one is the cost of the the structure, right? And that limit the width of the bund. You cannot arbitrarily increase, because increasing even by a few centimeters, it may cost in terms of lakhs of rupees. Because if you take the perimeter of the river, for example, in our case, we have proposed 200 meter by 200 meter pond. So approximately 800 meter is the, what you can say, perimeter, even if I consider it as a square. So 800 meter is a perimeter, and in this 800 meter, if you increase by 30 centimeter, and that too the width of the top bund width of the 2 meter, you just check how much amount of earthwork is required and what will be its cost.
Sir, again he is asking that since the soil type is clayey up to 9-meter depth, will you still plan to provide gabions for slope protection? Clayey in itself is low permeable.
No, the globe. See,
sir, I'm sorry.
Yeah,
I'm
please,
sorry.
please.
This was a kind of confusion. This is not a question anymore.
Okay. Yes, any other question?
Sir, last question is by Saurabh Nayak. He is saying that my location Jalgaon, Maharashtra, mostly basalt rock. The percolation of water through basalt rock is very less. Which techniques are best suitable for this condition?
Saurabh, it depends upon how much budget you have, right? That is number one. And number two, that the basalt rock, what is the depth of your basalt rock? Because some time back I was discussing with one of the assistant professor in Nasik Military Engineering College, and they were also facing the same type of a problem. But while discussing with him, I come across that there were mines near their institute, right? Old abandoned mines. And then then instead of going for recharging into the ground, I proposed them that you can go for a surface drain which take the water to the abandoned mines, and then they divert the water there. So it all depends upon the geology of the area, right? Geology of your location, and based on that, the recharging technique can be recommended.
Okay, thank you, sir.
Okay, sir. No other questions are there. If participants want to ask anything, they can unmute and ask directly. Meanwhile, all the participants are requested to fill the attendance link. The link is given in the chat box. Sir, I think there are no further questions.
Okay, then thank you very much. We have come to an end of today's session, and we will again meet tomorrow at 7 p.m. Those who are traveling to Surat, if you have any question, you can ask me or you can put it in the chat box. Thank you very much and good night.
Sir, can we request all the participants to switch on their camera?
Yes. We can take one pic with all the participants.
I request all the participants, please switch on their camera. Okay. Thank you, everyone. Thank you, sir.
Thank you and good night. Join tomorrow at 7 p.m.